Hello class, today we'll be talking about polymorphism. My name is Daniel Fichtel, I am a sophomore at the University of Michigan and I am a computer science major. So the word polymorphism literally means many forms. And in the context of programming, which I will be talking about it in, polymorphism refers to the ability for a piece of code to behave differently depending on the context that it's used in. So we have three types of polymorphism. We have ADHOC polymorphism, we have parametric polymorphism, and subtype polymorphism. So ADHOC polymorphism is function overloading. Parametric polymorphism is just in the form of templates. I'll get into that later. And the third is subtype polymorphism, which allows a derived class object to be used where a base class object is expected. I will not be talking about that today. It's a bit more complicated, and I do not have the time. So with ADHOC, it's basically you can have functions that have the same name but do different things depending on what the function inputs are. So let's say we have function return type int, same with foo, and this accepts a integer, and let's call that integer a. And let's say we have another function. So the point of function overloading is to have the same function name, and then those functions do different things depending on the name of them. So let's say we have another function void. It's a void function, no return type, and let's name that foo as well. And let's say this accepts a string. And let's name that string b. So your compiler will be able to differentiate which function to choose in your context depending on the input type of what you do. So let's say you call the function. Let's say you have a string in your program, and the string's named like a string, str. Your function or your program will call this function because of the type the function accepts, which is a string. You can also differentiate the number of parameters that your function takes. So to show you an example, let's say both these accept integers. Let's name b, and then this one accepts a string too. So your compiler will also be able to differentiate which functions to use based on the number of inputs and the type. The good thing to know is that the return type of your function, your compiler can't differentiate which function to use just based on the return type. So let's say we have both these accept integers and different return types. So this code will not compile because your compiler just can't differentiate which one to use because the return type means nothing to it. Okay. And now let's move on to templates. So the point of templates is to reduce code duplication because you don't want to have to write the same lines of code with just like the only thing that differs is the type name, because that would be pretty inefficient. And let's say you write like 5 classes for like int, char, double, string. Let's say you have like 5 different classes, and let's say you have a bug in your insert function for like let's say you're writing the standard template library vector. Let's say you write the insert function and then you mess up, there's a small bug. You'd have to go through every single class that you've created for vector, and you'd have to fix that bug in every single place that it is, which would be very annoying. So that's why they came up with this thing called templating. So in order to take advantage of templating, you have to, let's say you declare a class vector, and then you put this template type name t on top, and you would replace the type. Let's say your type is an int. You replace int. So let's say you've like a vector class and it's fully written in integers. So you would replace all the ints with t, and then now your vector class would work for any data type that you wanted to use. You can even throw in an abstract data type and it would work with templating. So to give you an example of a templated class, basically everything, or a lot of things are templated. Let's say like vector, standard template library vector is templated, and you can tell because you're required to declare the type when you're creating an instance of a vector. So whenever you're declaring a vector, you have to do these angle braces and declare the type int, and then this will give you a vector of integers. And if you were to declare your functions outside of the class, you would just have to use the same syntax. You'd have to do like type template, type name, you have to write that. Template, type name, t, and then you would define your function below. So you do, let's say vector, let's say int, no, don't do that, t. Type t, let's say what returns a type? Let's say like, let's pretend we have a find function in our vector, t find colon because it's a member function in the class vector. And the one thing about templating is it's hard to separate the code because usually you're supposed to have a header file with all the functions that you have, all the member variables, all that, and then you have your CPP file where you have all the implementations of those functions. But with templating, it's hard to I'm pretty sure you can't split them up. You can't have like a separate, or it's like a lot harder to link the two. So in 2A, you're gonna have to implement your templated functions within the header. So all the implementations will go within the header file. And that is all I have for you guys today. If you have any questions, leave them in the comments. Let me know. Thank you guys for listening.